Hello, my name is Sam Glick, and I'm here with the Engineerinators, and we will be presenting our running application. This application will analyze users' data of velocity, acceleration, and position of their run, and show the user in an effective way what their run looks like. The two sensors we used were a position sensor, taking our position data as well as our speed and velocity data, as well as an acceleration sensor, taking in our acceleration data in the proper Z direction based on the orientation of our phone. An important disclaimer to place before going any further is that this group, we have created all of our code as a group of three, having one person type while the other two people researched and looked up how to create code. So each of the coding elements in this presentation were a group process. However, they will be presented individually.
So I'll be presenting our app itself. As you can see, it's got 3 graphs, 2 tables, and a variety of other functions. First of all, we have a button to load in the data from your phone sensor. So I'm going to open the acceleration file, the position file, and the velocity file. And then as well, I'm going to load in the raw data for use later. As you can see, it has successfully graphed acceleration, velocity, and distance. Clearly the data isn't perfect, but it did graph correctly. And we have the 2 tables to display the data values as well. Next, there's a button to save as a comma space value file, which will save it on your computer as one file for each of the tables. The load data to ThingSpeak button will take the data from the tables and load it to ThingSpeak, which can be seen right over here. This is our data that we selected from the table. And once it is loaded to ThingSpeak, it will send a notification to Twitter as well, saying that you just went on a run. This button here that reads from ThingSpeak and uses the data that it pulls from ThingSpeak to do some calculations. If I click it, we have the average speed in miles per hour of the data on ThingSpeak, the standard deviation in miles per hour, and the miles run in miles. The last function of our app is the map function, which is right here. If you click this button and load in the raw data file, it brings up a street view map of the entire course that you ran. We have a little bit of a blip in our data, but it maps it correctly based on what the data was. Now we are going to discuss our code. Starting from the top, all of this was entered in automatically by the MATLAB app editor. We defined a couple of public properties up here just for convenience sake. We have the channel ID, write API key, and read API key that we will use later.
Okay, so first our data, we needed to load the files from elsewhere in the computer. We used the UI get file feature, which downloaded the files that we had taken from our phone and loaded to the MATLAB drive, and we put those on our app designer drive and we loaded them in. And then we described which variables we would be using that were held in our files using time Excel or Excel value, which was our timestamp and our actual value. And we repeated that process for our position array, our velocity array, as well as our raw data file. Now we use these to place certain arrays of data such as timestamp and velocity values into a plot function to plot the values on a graph. And we also used the same values to place the data that we had taken from our files into a table by concatenating the arrays that we had, and made sure to specify which axes the tables were going into.
This function here is from the Save as CSV button. It is a pretty simple function. It uses the built-in MATLAB function write table and simply saves the data in one of the tables to app speed and position.csv. That's the speed and position table. And the other table, the acceleration table, saves as app acceleration.csv.
So here's the callback for the read from ThingSpeak button, which takes the data from ThingSpeak and analyzes it in different ways. So the first thing we have is it's reading the velocity from ThingSpeak variable there. uses the ThingSpeak read function to get the data from ThingSpeak that is in field 2, which is velocity. And then it takes average velocity and displays that in the app as the average velocity of your run in miles per hour. We also took the standard deviation by using the standard deviation function and also displayed that in miles per hour. And then the last thing that we did to analyze the data was to take the integral of the absolute value of velocity in order to calculate the total distance traveled during your run. And we displayed that in the app also. We also use the ThingSpeak write function in order to write all of the data. We wrote position and velocity into ThingSpeak, as you saw earlier. And the last function that we had was the map. And what I did there was I took the longitude and latitude from the position sensor, and I was able to create arrays from those and use the geoplot function to map the exact route and labeling the start and end point of your run.
The rest of the data in the app is all things that were loaded in automatically by MATLAB.
Now, if we were to do this problem again, we would use different data, including data with more data points as well as less data points, as well as data with a larger range and a smaller range to see how our code works with different types of data. We would also compare our personal data with the data of other runners to maybe calculate or compare our splits compared to other people's splits, or compare who ran the most in a certain group. We would also take out outliers, which are easily put in by removing your phone from your pocket with the iPhone sensor, because it changes the orientation, and our new code would remove those. And then we would also find your splits per mile or kilometer, whichever you specify, in our next version.
Thank you for watching our video, and we hope you enjoyed our app.
Thank you so much.